This is the lesson from Thursday, November 1st, and it is section 9-5, scientific notation. So, back when mathematicians and scientists were all working together, they found out that they needed a way to be able to write really, really large numbers or really, really small numbers in kind of a shorthand, because it wouldn't fit on the calculators, it took up tons of paper, so they came up with scientific notation, which is a shorter way to write these really, really large or really, really small numbers. So the two numbers written here on this paper are written in what's called standard form or standard notation. That's just the regular number. But it would be easier if we could write this first number like this, as a product with a decimal number and a power of 10. The same thing with the really, really small number here, a decimal number and a power of 10. Numbers that are written this way are said to be in scientific notation. And this lesson is going to teach you how to change a standard number, a standard form number, into scientific notation just by moving the decimal. So to change a regular standard notation number into scientific notation, we are going to, all we have to do is move the decimal, either right or left. Okay? So the direction and the number of times the decimal is moved determines the power and the sign of the exponent. So depending on where we move it and how many times we move, that's going to give us our exponent. So notice here the standard form number was 5,785. So we have to get the decimal to where there's only one non-zero number to the left of the decimal. So we're going to move it 3 hops, and the resulting decimal is 5.785. Since we moved it 3 hops to the left, we're going to make it a positive 3 for the exponent. Look at this one. Since we have to move our decimal to where we have only one number to the left side of the decimal, we're going to move it between the 7 and the 4. So that's 4 hops. And since we went to the right, it's going to be a negative exponent. So we're making this number larger for the decimal, so we go with the smaller exponent. This one we're making smaller when we go to the decimal, so we go to the larger exponent. That's one way you can remember the left and right. Okay, so remember, for correct scientific notation, there should be only one number, 1 through 9, on the left-hand side of the decimal. So let's look for which one of these 6 are going to be in the correct scientific notation format. A has one number to the left of the decimal. It's an 8, so that one's good. This has only one number to the left of the decimal, 4, so that one's fine. Now letter C has 2 digits to the left of the decimal, so that would not be the correct scientific notation. We're going to circle the ones that are. Okay, I'm not going to circle C because of that 11. I would have to have the decimal in between the 2 ones. Letter D is fine because it has one number to the left of the decimal. Letter E is not okay because there's no number, there's just a 0 to the left of the decimal. Has to be between 1 and 9. And F is not in scientific notation because it has 184 to the left of the decimal. It can only be 1 digit. Okay, so let me show you how this is going to work. If I have a standard form number, I know the decimal is at the end, and I know I have to move the decimal to where there's only one non-zero number to the left of the decimal. So my new decimal number is 4.25, and I jumped 2 places to the left, so it's going to be a positive 2 power. Look at this one. I need to get my decimal to where there's 1 place to the left. So my new decimal number is 7.14, and that's going to be times 10 to the negative 1 power because I went to the right. 70, I have to jump 1 time to the left, so that's going to be 7 times 10 to the first power, and I don't have to write that 1 since it's the first power. This decimal must move 4 places to the right, so my new decimal number is 5.48 times 10, 1, 2, 3, 4, to the negative 4 power. One way that I remember if my exponent has to be negative or positive is if the number in standard form is greater than 1, it's going to be a positive exponent, but if it's less than 1, like these two, it's going to be a negative exponent. Okay? Now here's a couple more. Let's look at these real quick. This decimal has to move 1 place to the right, so that's 5.02. And since it was less than 1 when I started, it's going to be a negative 1 exponent. This one must move 4 jumps, so it's going to be 5 times 10 to the negative 4 because it started out less than 1. Couple more. 1, 2, 3. That's going to be 3.584 times 10 to the third power because I started out with a number greater than 1. And then 10 in scientific notation is going to be 1 times 10 to the first power, but I don't have to write the first power. Okay. Now the rest of these can be for practice, but let me show you that part of this is to go from scientific notation to standard form. So let's look at this bottom section. When you're going from scientific notation to standard form, the decimal tells you how many places to move your decimal and in which direction. Okay? So in this case, I'm going to move my decimal 4 times. So if I start with 3.64 and I have to move it 4 times, it's positive, so I'm going to make this bigger. So I'm going to the right. 1, 2, 3, 4. And that leaves me with some empty spaces. I have to fill those in with zeros. Okay, so this actual number in standard form is 36,400. So you have to move your decimal, and then if you have to add zeros, you have to add zeros. So let's look at this one. This is 3.9734. I've got to move it 5 places to the right because positive means it's getting bigger. So 1, 2, 3, 4, 5. So I'm going to have to add 1 0. 397340. And there's my standard form number. Okay. This one, if I start with 6.285 and I'm going to go in the positive direction, 3 jumps. 1, 2, 3. That one is 6,285. I don't have to add zeros to that. Now let's come over here and do a couple with the negative exponents. So I'm going to start with 2.97. Since this is negative, I'm going to go to the left 4 places. 1, 2, 3, 4. Again, I can't just have blanks. I have to put zeros in those blanks. So my new answer is going to be this in standard form. All right, 3.88. 10 to the negative 2, so it has to be made smaller. 1, 2. I got to add a 0. So it's going to be 0.0388. 5.65 times 10 to the negative 1. And so I'm going to go 1 place, and my answer is going to be 0.565. So that gives you a good example of how to do the positive exponents. You move to the right, the negative exponents, you move to the left. Now let's take a look on the back and let's see how we would compare scientific notation. We're actually going to do this part of the lesson tomorrow in class on Friday, November 2nd, but I'm going to go ahead and include this on the same video since it's all related. So when we're comparing and ordering scientific notation, the first thing you do is compare exponents. You look at the exponents, and the greater the exponent, then that's the greater scientific notation. If the exponents are equal is the only time you have to go to step 2. So step 2, only if the exponents are equal. And then you look at the decimal number. So you compare the decimal numbers. And if it's the greater decimal number is the greater scientific notation. So it's pretty straightforward if you'll just remember what to do. Let me show you a couple of examples. I'm going to write less than, greater than, or equal to for each pair. So remember, the first step is to compare exponents. So which one of these exponents is greater? Negative 2 is greater than negative 5. So I know automatically my symbol is going to be that. Let's look at number 2. I look at my exponents first, but oops, these two are equal. So now I have to look at my decimal numbers. Which one is greater? 9.14 is greater than 3.434. So this is also going to be in that direction. Okay? Now, here's what you're going to do if you're given a group of scientific notation numbers and you're asked to put them in order. Now, you have to know what ascending and descending means. Ascending means going up, so it means least to greatest. And descending means coming down, so it means greatest to least. So here's how I would use the rules that I know to order the following numbers. These are going to go in ascending order. So that's going to be least to greatest. So I'm first going to look at the exponents. There's a 3, a 15, oh, there's 2 3s. So I know my 3s are going to come first because that's lower than the 15, but now I have to look at the decimal numbers to see which one is less, and the 4 is less than the 7. So my 4.53 times 10 to the third is going to be my first number, my least number. Then my 7.4 times 10 to the third. And then finally 3.289 times 10 to the 15th is the greatest number. So always look at the exponents first and then only look at the decimal numbers if your exponents are equal. So now I'm putting this next group in descending order, which means greatest to least. So I can see negative 5, negative 12, and negative 5. So negative 5 is the largest exponent, but I have 2 of them. So now I have to look at the decimal numbers. 2.5 is more than 2.4. So I know that 2.53 times 10 to the negative 5th power is my greatest number. Then my other negative 5 exponent comes next. And then finally my 8.5 times 10 to the negative 12. Okay, so exponents first and then decimals.